Welcome back to my class. Today we want to look at type conversion and typecasting. All along we've been talking about rem. We have been looking at the concept of type as rem, right? So I am going to look at one rem, right? And then another rem. I'll put this one here. Now this one is an integer rem, right? And then this one is a float rem. I told you in my last class that this float rem has now this float rem is actually higher than this integer rem, right? Now you want to carry out an arithmetic calculation that involves an integer and a float. What do you think will happen? There will be conflict, meaning you have data inside this rem and you have data inside this rem. Say for example, I declare a variable a, and then I assign this variable, I say int, right, a, and I assign 5 to it. Then I have another one, float b, and I assign 3.5 to it, and then I close. Then I want to carry out an arithmetic calculation, which will be c. I will assign a plus b, and then this is this. So what do you think will be the data type of C? Now, in C language, when you have two different data types, and you try to do this arithmetic calculation, the smaller data type will automatically be promoted to the higher one before you can do this calculation. So in this case now, you have this one as an integer, right? Then you have this one as float. Float is higher data type than the integer. So the system will automatically convert the lower one to the higher one. So this return type for this C will be what? Float. Now, if this return type is going to be float, it means the compiler will implicitly, so there are two types of this type conversion. So one is what? Implicit conversion, right? And then explicit conversion. So this is this, and then this. Now, this implicit one is that the compiler will internally do that conversion. So the compiler will promote this one to a float. So once the compiler promotes this to a float, it's no longer in the integer rem. It will move it to what? To this float rem. Then this arithmetic can now take place inside the float rem and then assign to this other one, right? So the compiler does that promotion automatically because you are promoting from a lower rem to a higher rem. So the compiler can do it. You are not going to lose any data when you are moving from a lower rem to a higher rem. That means there is enough space to accommodate what is coming from a smaller space. So the compiler will do that automatically. That is implicit what? Conversion. So the answer to this will now become what? This will be what? 3. This will be 5.0. This is the float plus 3.5. And this one will give us 8.5. Right? This is what will be stored inside C. So the compiler does that. But what if you want to move from a higher rem to a lower rem? That is what? Demotion. This first one was what? Promotion. You are promoting from a lower rem to a higher rem. And the compiler will do that implicitly. But what if you want to move from a higher rem to a lower rem? That is demotion. How are you going to do it? Let's say, in that case, I do something like this. I say A, right? This one is float. And then I assign 5.3 to it, right? Then I now say int b equals to what? That is assign a to int b. Now, when I do this is not going to work. Why? Because this is a float, and then I want to move this to this. Automatically, what this will give me will be what? It will just give me only this. Now, because that decision cannot just be taken by the compiler without letting the developer know. So the developer will have to do what? An explicit conversion, meaning telling the compiler, I want you to do this conversion. I am aware of it. Because when you are moving from a higher RAM to a lower RAM, you are going to lose data. You have something inside a bigger space, and then you are moving it to a smaller space. That smaller space will not be able to contain everything in that bigger space. So you need to tell the person that this smaller space, not everything in the bigger space will go into it. Now, that is exactly what is happening. So for you to do that, you will call what we call typecasting. So you have to use the typecast operator. And how would that work? That will simply mean that on this side, I am going to put the RAM that I want to move to. I have to put it inside parentheses like this. Then I will say A. Then I will close this. So this is a typecast operator, this one, stating that I want this A to be converted to an integer. And at that point, it will give me what? 5. I will lose this part. That is what typecasting is all about. So the first one that we did was promoting an integer to a float, which is what? An implicit what? Conversion. While this second one now is an explicit conversion, where I have to state that I'm aware of this demotion. So go ahead and bring it down to the data type that I want. So there are different data types, and they have their different capability. You understand me? So I want you to understand that every time you are bringing a data type from a higher RAM to a lower RAM, you have to typecast. And this is what that typecasting is all about. So if, for example, I say that I have two, let's say I have two variables. I declare two variables, int sum, right? Then I assign 15 to it, or I assign 17 to it. Then I say count, I assign 5 to it, right? I have this. Then I now declare another variable, double. This double, and I'll say double is what? Mean. That is the data type of this variable, mean. Then I will now say mean equals to what? Sum divided by what? Count. What do you think will happen? This one, this sum and this count, they are in what? They are in the integer data type. Now, when I carry out this arithmetic calculation, my value is going to be stored in mean. And mean is double, which is what? Float. So this is a higher RAM than this one. Now, if I do this calculation, that will be what? 17 over 5. And that will give me 3.4. That is what it will give me. But if I do this calculation like this, which is the whole of this is going to take place in the integer RAM. And in integer, I cannot have this. So automatically, once this calculation is done, it will cut off this one. And then it will store this value in the mean, right? And it will store it as 3.0. This side has to be 60. 3.0. Now, if you look at this is wrong. This value is wrong, right? The value that I want to achieve is what? 3.4. 1, 2, 3, 4, 5. 3.4. That is what I want to achieve. But because I did this arithmetic calculation inside the integer RAM, because this is an integer, this is an integer, it's going to give me 3 as 0, right? And then it will assign that 3 to this min, which is double, that is the float rem, and automatically it's going to give it to me in this format. But it has removed this. But I want it to also capture this 4. So what will I do? I have to specifically promote one of these to the higher rem, to the rem of this min, which is what? The double. So that is where I will bring in the typecasting. So on this side, I will simply say I will say I will do this, then I will say I will say double, right? And then I will say sum. Then I will say count, right? Now, because I have done this promotion, I have explicitly typecast this sum from what? From the integer rem to the double rem, which is the float rem. I have promoted it. Implicitly, the compiler will promote this count too, because it will not be able to carry out this division on 2 different rems. So the compiler will automatically, implicitly convert this count also to double before the division will take place. Now, once the division takes place, it will now give me 17 divided by 5. That will be what? 3.4. So this is happening inside the double rem, which is the float rem, right? Before now assigning it to this variable, which is min. So it will now give me min will give me 3.4, 1, 2, 3, 4, 5, 6. So this is what I want, and it will give me this as my output. So it is very important that you must understand when to use the typecasting and when not to use it. Otherwise, you will get a wrong value as your output. You have to be very careful. So that is what will happen in this class. So that's what I want to show you, how to do what? Type conversion and typecasting. If it is promotion, that is going from a lower rem to a higher data type, that is what? Promotion. The compiler will automatically do that implicitly. But if it is demotion, meaning coming down from a higher rem to a lower rem, from a higher data type to a lower data type, then you have to explicitly typecast. So you must understand how to play with that, else your program will give you a wrong output. So that is what I want to show you in this class. So till we see in the next class. Bye-bye.